to Study Time, a televised home learning program produced by Rwanda Education Board.
Dear students of Senior 3 Chemistry class, I want to invite you in this session of TV learning programs. We'll be looking at the unit number 8, which is about the electrolysis and its application. And I'm very happy to be with you once again. We are just going to learn, we are going to look at our lesson number 3 of this unit, which is about the calculation of the oxidation state. This is the most easiest. This is very easy, as simple as eating ugali. So you know when you swallow the ugali, it just throws, the moment you put it in the mouth, you feel it just moving down the throat without any energy put in. Even the chewing is very easy. It's not like chewing any other type of the food. So that is why I'm saying it is as easy, because it involves addition and subtraction and multiplication. And actually it is the simplest of those concepts, the addition and subtraction. First of all, what we need to know is the purpose of these oxidation numbers. Or we can, before we mention the purpose or the uses of these oxidation numbers, or why do we need to calculate them, do we still remember what the oxidation number or state means? Because this is lesson number 3. We have been talking about this. In the lesson number 1, lesson number 2, now lesson number 3. Can you state or can you define what the oxidation state means or the oxidation number? I hope so, but let me just only remind you about the oxidation state. So this is the number of the charges. This is the number of the charges that remain on, this is on the surface. On the surface of an atom, molecule, when all other electrons have been used in bonding. So remember the charges, that when we talk about the charges here, when we refer to the charges here, we have 2 types of charges, as you are well aware. 2 types of charges. You remember them? 2 types of ions, if I can make it more simpler. This is, we have the cations, or you can call it the cations, whichever definition, whichever pronunciation you use. The cations, remember these are positively charged ions. And then we have the anions, not onions, please, anions. These are negatively charged ions. So that is when the atom or a molecule, after combining and sharing and transferring of the electrons, what happens, what remains behind, not shared, or what is being transferred remains behind in form of a charge, and it can be either positive or negative. That is cation. Those are the states. And if we look at if we want to calculate these oxidation numbers or oxidation state, they are very important rules that we need to know, that we need always to memorize. We need to memorize these rules so that as we memorize them, they are simple rules, then we can be able to calculate with ease these oxidation numbers. The rules are over there on the screen. Please have a look at the screens. When you look at the screen, we have the element, and then we have oxidation state, and then exceptions. Those are 3 tables, if you can check. Then group 1 metals, in combined state, they will carry a positive 1 charge. In combined state, they will carry positive 1. Group 2 metals or elements, they will carry positive 2 in the combined state. Fluorine always carry negative 1. Oxygen carry negative 2. Chlorine carry negative 1. Hydrogen atom carry positive 1. So halogens will carry negative 1 in general, with exception of some few compounds. So when we come back to, when we look at the screen properly, we can see that oxygen carries a negative 2, but it is a negative 1 in peroxides. If you have peroxides, can you give examples of the peroxides? I hope so. So we have hydrogen peroxide, that is the common one, the common peroxide, hydrogen peroxide. So in peroxides, sodium peroxide and so many others. So in peroxides, oxygen carries negative 2. And oxygen carries positive 2 in that oxide. I think you can just look at on the screen, positive 2 in this oxide only. Chlorine, except in compounds of oxygen and fluorine. So if they are oxygen and fluorine, then chlorine will carry a negative 1. Hydrogen, positive 1. It is negative 1 in metal hydrides. For example, if you mention sodium hydride, this sodium hydride, magnesium hydride, like this, it means hydrogen is carrying negative 1. Negative 1. Very important information also that we will need as we are calculating. Sum of oxidation numbers for a neutral compound will add there even neutral element. Neutral compound. For example, if I say sodium sulfide, that's an example of a simple molecule. The sum of the oxidation numbers of these atoms, the sulfur and oxygen, is equivalent to 0. That one will help us so much, if you can remember. If we say sodium in neutral state, uncombined state, this one will carry a charge of 0. Sum of oxidation numbers for monoatomic ion or polyatomic ion is equal to the ion charge. What do I mean here? This is an example that if I have a compound, this compound may be, let me use this compound as an example. Manganese 7 ions. The negative charge, the sum of these two, the sum of the manganese and the sum, this is a polyatomic ion. It has more than one ion. So that's why we call it a polyatomic. Poly means many. The sum of these ions, the sum of the oxidation state of these elements is equal to this charge. You may have another one, NO3. What is the name of this? We call it a nitrate. These are radicals. The sum of nitrogen and oxygen is equal to -1. We have the sulfate, negative. The sum of sulfur and oxygen will be equal to -2, and so on and so on. That is very important. This information summarizes the rules that we can use to calculate the oxidation state. The oxidation state. Before I defined the oxidation state, I wanted to mention the most important purpose of these oxidation numbers. One, naming compounds. Naming compounds with various oxidation numbers. When I talk about the oxidation numbers, I can simplify this one as various because the word variance is common, with the different variance numbers. Take an example in compounds when we have iron. This is an example. If we have this compound, and then we have this compound, these are two chlorides of iron. Iron has got variable oxidation number, variable variance force in simple terms. So that is why the variance, the oxidation state, helps us to name this compound. This is iron 3 chloride. This is iron 2 chloride. But when we have magnesium, we don't need to mention the oxidation number because magnesium has got only one single variance, single oxidation number, oxidation state. So we say this is magnesium chloride. Magnesium chloride. Why? We don't need to mention the oxidation state of magnesium because it is only one. We don't need to change that one. So let's proceed and see how we can calculate the oxidation number of these compounds. We said these oxidation numbers can help. The most important here that we are talking about is naming the compounds. But the second important purpose is balancing redox reactions. Balancing redox reactions. You will see that one later on as you go higher in other levels. So here, let us look at the screen and see how we can balance these, or rather how we can calculate the oxidation number of sulfur in the following compounds. We'll try to go slowly. I hope you have your papers, you have your notebooks, and you have your pens ready with you. So that's why I'll be giving you some few seconds to write down because it is the addition. Let me first help you with the first one, part A. We need to calculate the oxidation state of sulfur in this compound, which is sulfur dioxide. Sulfur dioxide. We call it sulfur dioxide. Why do we call it sulfur? That is a trivial name. The chemical name is not sulfur dioxide. So how do we calculate? We say this is a neutral molecule. And therefore, the neutral molecule, if it is a neutral molecule, the sum of the oxidation numbers of atoms is equivalent to the number of charges. Do we have charges here? No, we don't have any charge here. So that means it is 0. The sum of the oxidation states will be equal to 0. So we need the oxidation state of sulfur. We can call it X or any other unknown later. You can use X. X is very common in mathematics. I don't know why they choose X, but you can call it even, you can even use another letter. So X plus, remember oxygen, we said oxygen carries a negative charge, except in hydrogen peroxide where it carries -1, and in other oxide that we mentioned, difluoride oxide, where it carries +2. So that is why you need to remember those rules. So this is X plus oxygen. Oxygen carries a -2, then times 2, this one will be equal to 0. That is X minus 4 is equal to 0. So X is equal to +4. Isn't this one, as I said, it is just simple addition and subtraction. Simple mathematics. Primary 3, 4 there. Now that means X, when you are recording the oxidation state, very important point to note for you. The oxidation state has to be negative or positive, or 0. 0 doesn't have any charge. So it has to be positive or negative. That's why we are putting here +4. Don't write it as 4 only. +4. So meaning the sulfur dioxide we are talking about, sulfur dioxide, the name of this compound, the chemical name is not sulfur dioxide. It is sulfur 4 oxide. In most of the books, you'll find that's what they are writing, sulfur 4 oxide. So when they write sulfur 4 oxide, you know that means they are referring to this. Let's look at the carbon dioxide, the common compound. Everybody knows carbon dioxide. So we calculate the oxidation state. This is carbon dioxide. If we calculate the oxidation state there, I hope you are doing so. So try to calculate, try to calculate and find the oxidation state of that compound of carbon in this. So we said this is X plus oxygen is -2 times 2, because there are 2 atoms together. This one will be equal to 0. There is no charge. Therefore, it will be X minus 4, which is equal to 0. So X is equal to +4. So the name of this compound, the chemical name, is not carbon dioxide. The chemical name is carbon 4 oxide. Carbon 4 oxide. Very important to note. What about the sulfur dioxide? Let us see, can we calculate this? This one is commonly known as sulfur trioxide. Can you calculate the oxidation state of sulfur here? That is X minus, no, plus, -2 times 3, which is equal to 0. No charge here. So if there is no charge, you don't need, you equate to 0 as we have said in the rules, remember. So this will be X minus 6, which is 0, equal to 0. So this is +6. Sulfur 6 oxide. That is the chemical name. Sulfur 6 oxide. Sulfur 6 oxide. And so on. Are we moving together? Do I make myself clear to you? I'm trying my best. So please make sure you are following. Let's calculate another oxidation state. Sulfur, what is the oxidation state here? So we'll need, this will be X minus, this oxygen is -2, remember, times 4. So we can say plus. This will be equaling to -2, the number of charges here. So you have said we are looking at, these ones are neutral compounds. The rule that we have said, the sum of the oxidation numbers of atoms in polyatomic ion is equivalent to the number of charges. That is what we mentioned. This is X minus 8, which will be equaling to -2. So this is X minus 2 plus 8. This one will be equaling to what? So no. X will be equaling to -2 plus 8. Just take this one, this side. So X will be equaling to +6. You can also look at part D, sulfite ion. This is a polyatomic ion. So you do it the same way, which will be X minus 2 times 3, which is equal to -2. So this is X minus 6, which is equal to -2. So X will be equaling to -2 plus 6, so which will be equaling to +4. That's how we calculate these oxidation numbers. So we can calculate the oxidation number of this molecule, which is sulfuric acid, the oxidation state of this. So this is a molecule. It has many atoms. But remember we said hydrogen in combined state carries a charge of +1 in the rules. So you need to always remember that in the rules. So what do? Hydrogen, there are 2. So that means each one is carrying one +1. So that's why we'll have 2 plus X. This is what we are looking for. Then plus -2 plus -2 times 4. You see here there are 4 atoms, but each oxygen atom is carrying a -2. So that is why we are putting that one. This is equal to 0 because there is no charge on this compound, on this sulfuric acid. So this is X plus, that is -8, which is equal to 0. So if we get the value, there is plus X here. This will be 2 plus X, then minus 8. So 2 plus, so what will be the value of X? X will be equaling to, what is this? 6, +6. So +6. That will be the value of X in this. So sulfur is in the oxidation state of +6. Let's look at now, these are compounds. You have, this is number 2 of the examples. Let's start with A of number 2, where you have, this is chlorine. So we need the oxidation state of chlorine in these compounds. So that means others, we are going to use the rules to calculate the oxidation state of the chlorine. So we have sodium, it is +1. It carries +1 in combined state. So that will be 1 plus -2. We are looking for the X, that's chlorine, plus X is equal to 0. So that is X plus 1 minus 2 is equal to 0. That's the same as this. So this will be the same as X minus 1, which will be equal to 0. So X is equal to +1 in that compound. If you have part B, where you have sodium chlorate, so you have 1 plus X, you are looking for chlorine, then plus -2 times 3. The whole compound is equated to 0 because the number of charges are 0. So that will be 1 plus X minus 6 is equal to 0. So 1 can get X direct. This will be equaling to, what will be the value of X? -5. -5. This is 1 plus X. This is 2 times 3. So the value of X will be -5. You need to calculate. So try even those, some other examples and see what you can get. Maybe lastly, I can do one for you. If you have X, part F, where you have chlorine, this is 7. So this will be, we'll need chlorine here, so that will be 2X, because that is what we are looking for, plus -2 times 7, which is equal to 0. So 2X is equal to, this one will be equal to 14 when we take this one. So X will be equaling to plus 7. That is how you get the oxidation numbers. These oxidation numbers, that's how they can be used to tell you whether the oxidation has taken place, as we looked at in the previous lessons, or reduction has taken place, when you can be able to calculate those oxidation states. And we said naming compounds, they are also important. In balancing complex reactions, for us who always balanced simple reactions, they can also help. Number 3, so but we can still, we can just give, I can just leave you with the homework. Try that one, please. It is just as simple as I said, as swallowing the ugari. Work out the oxidation state of those elements. Chlorine in hydrochloric acid, so the elements are indicated. They all contain chlorine, so you calculate the oxidation state of chlorine. Phosphorus in all these compounds that contain the phosphorus. Chromium in these two, they also contain the chromium. This is all about the oxidation states. So what do we need to remember? The definition and even the purposes. 1, we said balancing complex reactions. 2, naming compounds. And 3, they can also tell us whether the reaction is oxidation or reduction. Thank you so much for being with me in this, all throughout in the 30-minute session. I hope to be with you in the next lesson. It will be very interesting where we'll be applying these oxidation states and numbers. Have a good day. Stay safe. I hope to meet you in the next lesson. Bye-bye.